Hi, we're going to continue talking about area. Here we're going to be talking about area of triangles as well as area of other figures. For a triangle, again, the area is the stuff inside. Area is 1/2 b times h, where b is the base of the triangle and h is the height of the triangle. Whenever you're looking at a right triangle like the one here, it's pretty easy to figure out the height and the base. Those are the legs of the right triangle. Because you're going to be multiplying these numbers, the order doesn't really matter. So don't get hung up on which one is the base and which one is the height. Whenever you're looking at like a triangle like this, it doesn't matter, right? So if it's turned like this, what it is labeled as the base could be used as the height. It doesn't really matter. All right, so here's an example. If the height is 8 and the base is 7, the area is 1/2 of 8 times 7. Half of 8 is 4, so we take 4 times 7 and get 28. So you see I switched the 8 and 7 up there because it's easier to find half of 8 than it is to find half of 7. When you don't have a right triangle, you have to create a right triangle in order to determine the height. You draw a straight line from the vertex to form a right angle, and this is the peak, the highest point. All right, so if you have a triangle like this, you would draw the height down the middle of that triangle. Your base is this total bottom length here. All right. We're also going to be using Pythagorean theorem. Pythagorean theorem is a squared plus b squared equals c squared. Some of these things, again, because the ACT does not give you a reference sheet, you're going to have to memorize. So Pythagorean theorem is one of those formulas you need to memorize, as well as the area and perimeter formulas. But you're also going to have to be familiar with different vocabulary. So here's some triangle vocabulary. Scalene are triangles that have no equal sides, and we're talking about side length. Isosceles triangles have 2 equal sides, and equilateral triangles have 3 sides. For other figures, many things you can break into these basic figures like rectangles, squares, circles, and triangles. But if you have something like a trapezoid, there's a specific formula for that. And the area of a trapezoid is 1/2 the height times the sum of the bases. But if you can't remember that formula, you can just break it into those pieces. So like, for example, here's a hexagon. You can break this into 2 triangles and a rectangle. And you just find the 3 different areas and you add those together. All right. So here's an ACT type example. What is the area of the isosceles right triangle with a hypotenuse of 12? Remember, isosceles means 2 congruent, which means equal length, sides. So in order to do this, we need to... All right, sorry about that. So the Pythagorean theorem, again, is a squared plus b squared equals c squared. So again, if you're not sure, draw the picture. So here's my triangle. Because it's isosceles, I know that these 2 sides are the same. And then my hypotenuse, the side across from the right angle, is 12. So I have a squared plus b squared equals c squared. A and b are x. They're the same, so it doesn't matter. So I get x squared plus x squared equals 12 squared. X squared plus x squared is 2x squared. 12 squared is 144. I take and divide by 2 so I can isolate that x squared. So x squared equals 72. Remember, the way we find the area of a right triangle is find the area of any triangle is 1/2 the base times the height. Here the base is x, the height is x. So these 2 values are the base and height. If I were just to multiply the base and height together, I would get 72. So what I need to do to find the area of that is find half of 72. So half of 72 is 36. All right. I'm going to send you some practice problems with this as well. If you have any questions, please don't hesitate to ask. Good luck.